This lesson will cover Unit 3, Acquisition 4, and we're talking about net ionic equations. So first I want to go over the three different types of equations that it's going to ask you to write. First, if the problem says to write the molecular equation, write the molecular equation. This is going to be the full balanced equation. Reactants produce products and it needs to be balanced. We're always going to start with the molecular equation, and then we can break that down into what is called the total ionic equation. This is kind of like our transition step to get from molecular to net ionic. When we go from molecular to total ionic, we are going to write all aqueous compounds as dissociated ions. Dissociation is just the process of an ionic compound breaking down into its individual ions. Let's say I had the ionic compound calcium chloride, and it is an aqueous compound. If I were to dissociate it, I'm going to break it up into its individual ions. I have one calcium, and calcium as an ion has a charge of 2+. This subscript 2 tells me I have 2 chloride ions. Chloride has a charge of -1. One thing that's really important when we are writing our total ionic equation is that you never break up solids. Never break up solids. So if you have a compound that is insoluble, you are not going to dissociate it, you're not going to break it up into its individual ions. We also have something called the net ionic equation. In the net ionic equation, we include only the species involved in the chemical reaction. So just because an ion is in the reaction doesn't mean it actually participates in the reaction. We have some ions that we call spectator ions. The way you're going to identify spectator ions is they are the ions that are present in both the reactants and products. They're going to get canceled out. And we call these spectator ions. And I'll show you what I mean by that. It's only the individual ions that you can cancel out. If they're part of an ionic compound, you could not cancel them out. first one. Given sodium chloride and silver nitrate, we're going to start by writing the molecular equation. So I'm going to leave a space in case I need to balance. And I'm going to start with NaCl. First thing you want to do is go to our solubility table, look up sodium chloride. Sodium chloride is soluble, so it's aqueous. Plus silver nitrate. Find silver, find nitrate, see where they intersect. It would be soluble. An ionic compound that dissolves in water is considered aqueous, so it gets the AQ. Next, we have to predict products. So step 1, determine the charge of all the reactants. Step 2, figure out who's going to bond with who. Positive ion of the first will go with negative of the second. I'm going to go back to my solubility table, find sodium, find nitrate. It is also soluble, so it gets the AQ. Silver will bond with chloride. Back to my solubility table. Silver chloride is insoluble, so it's going to form a solid. Next step would be to go through and balance, and this one is already balanced. So we could either leave it blank or we could put ones in there. B, we are going to take this molecular equation and we are going to convert it to the total ionic equation. So again, in the total ionic equation, all that we're going to do is take the aqueous compounds and dissociate them, or break them up into their individual ions. Sodium chloride is aqueous. So that's going to break up into sodium ions and chloride ions. This is an ionic equation. Ions have charge. You need to write the charges in. Silver nitrate is also aqueous, so it's going to dissociate. It is going to break up into silver ions and nitrate ions. I'm going to run out of room on my page, so I'm going to do my products down here. Sodium nitrate, again, is aqueous. So it breaks up into sodium ions and nitrate ions. Lastly, never break up solids. Silver chloride is a solid, so I'm not going to break it up. I'm going to leave it as an ionic compound, AgCl. So this would be my total ionic equation. Question C. We could now convert to the net ionic equation. So in the net ionic equation, ions that are present in both the reactants and the products will get canceled out. So notice that I have a sodium ion on the reactant side and I have sodium ions on the product side. If you have an ion that's on both sides, it can get canceled out. You would not be able to cancel out chloride It is an ion on the reactant side, but it's part of an ionic compound on the product side. So you cannot cancel it out. Same thing with silver. But I can cancel out nitrate. I have nitrate ions on each side. The net ionic equation is whatever is left over. So I have chloride ions plus silver ions. Producing. The only thing that is left on the product side, on the right side of the arrow, is silver chloride. So this would be your net ionic equation. Lastly, you will be asked to identify the spectator ions. Spectator ions are what got canceled out. I canceled out sodium, and I canceled out nitrate. They are spectator ions because they don't participate in the reaction. They're just watching. They're like a spectator. Alright, let's try another one. Sodium hydroxide plus copper 2 chloride. We're going to start with the molecular equation. And we need to use our solubility table. Sodium hydroxide is soluble. Plus copper 2 chloride. Find copper 2, find chloride. This ionic compound is also soluble, so it is aqueous. We need to predict our products. First step is to determine the charge of all the ions in the reactants. By now we should know how to figure out charge. Positive of the first would bond with negative of the second. Sodium chloride is soluble. Remember, anytime you need more than one polyatomic ion, it goes in parentheses. So I would need 2 hydroxides to cancel out that positive 2 charge of copper. Since I need 2 hydroxides, OH goes in parentheses. Copper 2 hydroxide is insoluble. So it gets the solid. Before we move on, we need to balance this equation. I see that I have 2 chlorides on the reactant side, but only 1 over here. That now gives me 2 sodiums, so I can add a 2 over here. That gives me 2 hydroxides, and I have 2 hydroxides, so we're balanced. Next, the total ionic equation. So again, we are going to break down all of our aqueous compounds into their individual ions. But we also want our equation to be balanced. So remember, coefficients go to both the cation and the anion. So bring that 2 down with you. So I have 2 Na, and it's an ionic equation. Ions have charge. I also have 2 hydroxides. Hydroxide has a charge of -1. Copper 2 chloride is also aqueous. It's going to dissociate into copper ions and chloride ions. I have 2 chlorides. The subscript tells me the number of chlorides that I have. So I'm going to bring that 2 down with me. And the nice thing, when you are doing this total ionic equation, we already figured out the charge of all of those ions. You just have to copy them down. Let's go to the product side. Sodium chloride is aqueous. I have 2 sodium ions and 2 chloride ions. Copper 2 hydroxide is a solid. We never break up solids. So this would be my total ionic equation. Net ionic equation. We're going to cancel out spectator ions. Spectator ions are going to be ions, not part of ionic compounds. You could only cancel them out if you see the ion on both the reactant side and the product side. I can cancel out my sodium ions, and I can cancel out my chloride ions. Whatever is left, I'm going to bring down. So I have 2 hydroxide plus copper 2 plus yields copper 2 hydroxide. So it's important to bring down those coefficients from when you balanced, because your net ionic equation also needs to be balanced. I have 2 hydroxides on the reactant side, and I have 2 hydroxides on the product side. I have 1 copper on each side, so the reaction is balanced. Last question for this problem. You also need to be able to identify the spectator ions. Spectator ions are the ions that are spectating. They're not participating in the chemical reaction. That would be sodium and chlorine. So if we were to do this reaction in the lab and we are mixing 2 aqueous solutions, we would be mixing 2 solutions together and a solid would be forming. Copper and hydroxide are involved in that reaction. They are reacting to produce the solid. Sodium is not involved in the reaction and chlorine is not involved in the reaction, so we would call them spectator. Let's look at one other example. Let's say we had this reaction. Aqueous chromium-3 nitrate plus iron 2 sulfate producing chromium-3 sulfate plus iron 2 nitrate. Sorry, ran out of room. and that's also aqueous. So this would be your molecular. Let's go right to total ionic. So again, in the total ionic, we are going to break apart every aqueous compound. So I have 2 chromiums, be careful when you're counting nitrates. Remember that the 3 multiplies in, but the 2 also multiplies in. So go back to when we learned how to count atoms. There would be 6 nitrates. Iron 2 sulfate is aqueous, so it dissociates. I would have 3 iron 2 plus ions, 3 sulfate ions, on the product side, 2 chromiums, 3 sulfates, iron 2 nitrate is also aqueous, so we're going to break it up, 3 iron ions, and then again, be careful when you're counting your ions. 2 nitrates times 3 would give me 6. If we were to go through and cancel out ions that are on both the reactant side and the product side, here I have 2 chromium 3 plus, 2 chromium 3 plus, it cancels. 6 nitrate, 6 nitrate, it cancels. 3 iron 2 plus, 3 iron 2 plus, it cancels. 3 sulfates, 3 sulfates. Notice that everything cancels, so there's nothing left for your net ionic equation. If every compound in both the reactants and products is aqueous, you can save yourself a whole bunch of work, and we would say no reaction. If you were to go to the lab and do this reaction, you would not see a reaction occur. So again, the key that you're looking for is every single compound in the entire reaction in both the reactants and the products. If they're all aqueous, it's going to be no reaction.